Mir ist es egal. Egal, okay, gut. Ich dachte nur, wenn die Leute, die da im Livestream zugucken, wenn die das gerne irgendwie auch verstehen wollen und die vielleicht von abroad sind, dann. Bitte? That's great. Okay. Then I'm going to do it in English. So, yeah, Kick-Ass software development. So who knows the movie Kick-Ass? Who has seen the movie Kick-Ass? Well, the first part, not the second one, because that sucks. The first one is really good. So, for those who have seen the movie, they know that already. Kick-Ass is just an ordinary guy. So he doesn't come from this planet Kryptonite, or he haven't been bitten by a radioactive spider. He's just an ordinary guy. And he walks the street and says one day, okay, I want to be a superhero and I want to fight criminalists. So, and for those who have seen the movie, they also saw that he got really, really beaten up the first time. So he went out, fighted criminalists, got beaten up. He got actually stabbed by a knife, driven over by a car afterwards. So really, really bad things happened to him. But then he stood up. He stood up again and did actually his second fight. So he stood up and did his second fight. He didn't stop at this point. He stood up and did his second fight, and all of a sudden other superheroes joined. So Hit Girl joined and Big Daddy joined. So it was a really superhero crew. And this is actually, if we take this and put it to software development, this is actually my talk in a nutshell, my elevator pitch here. So it's actually, there's a superhero in all of us. There's a superhero in all of us. We can really kick ass again in software development. We just have to go out and see what sucks and fix those things. So, but first I want to set some expectation here in this talk. So who's actually here to see some kick-ass code? Yeah, in this talk? Well, sorry. This is the only code you will see. You may leave now. Bye. So who wants to learn a new methodology? The new Agile, the new Scrum, the new Kanban, the new kick-ass methodology. Yeah? Okay, I have a warning for you. There is no kick-ass manifesto. Atlassian has not written a kick-ass manifesto, and for those who want a kick-ass, who think there's a kick-ass manifesto and who are here to get a certification, no. There will be no certification after this talk, guaranteed you. Okay, who just wants to kick ass? Oh, now you're a little bit scared here. You can see that. Yeah. So for those who want to kick ass, this is your freaking talk here. Yeah. And yeah, that's actually me with a mask, but it's pretty warm under that mask, so I haven't taken it with me. All right. So actually, how do you do kick-ass software development? How do you achieve that? How do you do kick-ass software development? 2 words. Use Java. Thank you and goodbye. Oh, well, okay, good. So the programming language is, of course, not so important. You can kick ass with Ruby, you can kick ass with C#, you can kick ass with PHP. Oh, I don't know. PHP programmers here in the room? No? One out. No, just kidding. So my PHP ages are, I think 10 years ago, the last line of code, PHP code I've written, so. But I care about software developers, and my name is Sven. I work for an Australian company called Atlassian, and I'm an ambassador, which is like an evangelist in other companies. So tweet me if you think this talk doesn't kick ass at all. Tweet me if you think this talk kicks ass. Whatever you want, just give your feedback. So, software development. I've just written some random things down when I thought, okay, what do I want to achieve in software development? And these are my random things. I want to have better software. Software that is better, that performs better, that is better in quality, whatever. Just better software. I want to have less overhead. I don't want to spend that much time in meetings. I just want to write code. That's what I want to do. I don't want to read emails that much. I want to write code. Faster development. Faster development is a good one. I want to actually have my features faster at the customer, so they can really see what I've been doing last week. So this is what I want. And all of this, I hope, makes happy customers. So I want happy customers, and when the customers are happy, I think we all have happy developers. So if you would have asked me, Sven, how do we achieve that? 5 years ago, I would have said, be agile. Agile is a solution for everything. Well, we just have small sprints, and at the end of the sprint, we show the customer, we give the software to the customer, fast development, the customer is happy, great. I told you, 5 years ago, I would have said that. Well, so what's actually the state of Agile in the year 2014? Where are we with Agile? Well, you hear more and more people bashing on Agile. So like Martin Verbruch, the Diabolic developer, who says something like, hey, if it compiles, then just ship it. Which is, I mean, really, we are professional developers. This is totally stupid. I mean, we have to give that to QA or test things and run it through the build server, make some tests, automated tests. We know that. But a little voice inside me says, yes, awesome, that's great. I want to just ship it. If it compiles, yeah, I don't want to care about all this stuff. Or the people from the dark manifesto of Agile software development who just replace some words in the Agile manifesto like individuals and interactions and not process and tools. Or the guys from the programming motherfucker scene. They say they didn't just replace some words, they replaced the whole manifesto. Every sentence they translated with, what's the real value in that? Programming motherfucker, that's the real value. So the question is, if we see all these people, all these guys, is Agile actually dead? Is it over? Are we waiting for the new thing to come? Well, I think Agile goes like every technology, methodology through this Gartner hype curve. Well, at the beginning, everybody thinks, wow, this is great, this is awesome, you have to try this. So the thought leaders say, you have to try this. Developers, you have to try this is so good. Then the early adopter says, yes, it solves all my problems. And then you adopt Agile, adopt the technology, and then you see, well, it actually doesn't solve all my problems. Actually, Agile introduces more problems because it makes things more transparent all of a sudden, so you get more problems maybe in your organization. So what should we do now that we know that? So we are somewhere on the downside. Maybe it's going up at the end, maybe not. So what we actually can do is wait for the next smart people, the next guru that shows up. Wait for the new Uncle Bob. Or, I don't know. Let's see, let's wait. Well, we all know that we shouldn't do that. We should stop following the next guru, and we should look at our own software development, what we are doing at our own company. What are we doing day in, day out? Change this and kick ass again. So this is what we should do. So here are my 4 ass-kicking topics. Brought with me. Deliver kick-ass software, 1 kick-ass team, kick-ass collaboration, kick-ass automation. And we start with deliver kick-ass software. So, kick-ass software. What is kick-ass software? I mean, for me, actually, kick-ass software is if my customer looks like this. Well, maybe not exactly like this. But if he smiles like this, like this guy here, if he's happy using my software, so he's getting up in the morning, being happy, going to the office, yes, I can use Sven software, great, woo. Then I pretty much know that I'm doing kick-ass software. We want to build the right thing. So how do we do that? How do we know that we build the right thing? Who here knows the Microsoft kin? This audience. 1, 2, okay, good. I didn't know the Microsoft kin before this talk. I just Googled for Microsoft software disasters, and this came up. And Microsoft, they wanted to do this cool mobile phone. I think it was 2010 or something. They wanted to do this cool mobile phone. You'd see it's a little bit looking like a BlackBerry, where people can type very, very fast. So it's for the young generation, Facebook integration, Twitter integration, Foursquare, you name it, everything is in there. So they can type very fast, type their messages, cool thing. They actually acquired a company who did this operation system on that one. So they acquired this company, spent, I don't know, a lot in marketing. Actually, they spent $1 billion just developing this phone. They brought it on the market. Nobody wanted it. Nobody wanted this phone. And then Microsoft did something very, very smart. After 40 days, they pulled the plug and they removed it from the market again. So very, very smart. They didn't try to fix it. They saw, we're not going to win this battle. It's over. We stop it. $1 billion down the toilet. So actually, how do we know that we built the right thing? Actually, before we built the right thing. So at Atlassian, we have one sentence that we say day in, day out, and this is called fake it till you make it. We can go so far with faking stuff. We can save so much money if we just go and fake stuff. So IBM, actually, they did something very, very cool, and this is decades ago. And this is the speech-to-text experiment. So they did this experiment where they said they developed have developed a software that turns speech into text. Great. So they took this software, took some people, set them in front of a microphone. There was just a microphone and a screen, and then people started speaking, and magically the words appeared on the screen. Cool, great. They didn't write one line of code. They just had a guy who could type very, very fast. He was sitting there with the headphones and typed very, very fast. And they faked the whole thing. And what IBM found out is that people cannot talk the whole day. They just cannot talk for the whole day, and then they cannot control the cursor like backspace, delete. It's not working. That's totally not working. So they found out. They stopped this. The development they didn't start even, so they stopped this project and said we're not going to develop it because it doesn't make sense to do it. Okay, but even one step before that, we can start faking stuff and see if stuff's working. So we can start one step before that, and that's what we also do at Atlassian. It's paper prototypes. And paper prototypes are a very, very cheap thing. You just need some glue, a scissors, some screwdriver, and a piece of paper. And then you draw your interface. What we do is we sit together with a designer or a few designers, developers, customers, and then we're doing paper prototype sessions, which maybe are 1.5 hour sessions. And in this paper prototype session, we take a user story, say we want to solve this here, we want to draw the UI for this, and then we're trying maybe 15 prototypes. And we throw 13 away from this paper prototypes and say, okay, these 13 they don't really work. And this is the good thing if you use paper. You can just throw it in the bin. You don't have a connection to it. If you already have put effort in making a nice design and writing some HTML code and all the stuff, so then you say, okay, I'm going to fix that. But here you just throw it away. A paper prototype looks a little bit like this. If you see that. If you can see that, that's a paper prototype, very, very cheap. I don't know what kind of software this is. Looks like an email software. So this is a cheap paper prototype that somebody built. But we're not just doing new, cool interfaces here. We all have running software out there. So, and we have to improve our software continuously. But which parts should we improve? Maybe we should throw away some parts. So how do we know that? Which parts are used? What is good? What is not good? We know that through feedback. We collect feedback. We want to have feedback from customers, how they use our software, what they think is good with our software, what they think is bad with our software. But how do we generate a kick-ass feedback experience? So 2 weeks ago, I went through Heathrow Airport, and there was this terminal here. And it says, how is your security today? And there were 3 terminals. I went through the security, saw this terminal, very easy to find. And it's very simple. It's also very simple. You just have a few buttons here, yeah, good, bad, in between. So it's very, very simple. And it's fast to submit. You just push a button and go on. Go to your plane. Very, very easy. If you want to have more detailed feedback, you can give that too. There are some cards to fill out. Great. That's a kick-ass feedback experience in my point of view. So we had this problem at Atlassian not this problem. We wanted to build for our product called Greenhopper. I don't know if anybody knows that here. Anybody knows Greenhopper? Well, it's not called Greenhopper anymore. It's now Jira Agile. Anyway, that was not a test, sorry. So it's now Jira Agile. So for Jira Agile, we wanted to have this new board. We wanted to make a new board experience. So it's an agile software, so there's a Scrum board, a Kanban board inside. So we wanted to make a new board. And what we wanted to have with this new board is we wanted to collect as much feedback as possible. So we wanted to create a kick-ass feedback experience for Jira Agile. So what we actually did is we created this button and we put it just on the header. So just on the header, there was this feedback button. So everybody could see it wherever they were in Jira Agile, they could see this button. So, and if you click on this button, very, very simple to fill out, just a few required fields, and you can fill them out very, very easily. And as you see, it's in application feedback, so you are not dragged to another web page. You're in the application. So, and then you press submit, and it's very, very fast, and you can see you end up where you have started. So you don't have to go back somewhere. You just end up where you have started. So to wrap this up, easy to find, very, very simple, and fast to submit. With this, we did this, and I think we tripled our feedback that we got. So we had a button down at the page like every web page has, send me feedback, please. And we tripled our feedback. So 3 times as much feedback as we had before. That's good. But how to deal with all this feedback? So, and actually you want to protect your developer a little bit from that feedback because you hired them to develop code. That's what they do. That's what they do day in, day out. They should write code. Actually, Google has coined a term for this, and it's called the shit umbrella. And the shit umbrella is, I mean, these numbers are I think 2 years old, so don't count on that. 100 developers in the Gmail team, and 425 million users. It's much more than that right now, I think. But still, that's just an example here. So, and if you see that, and if you count the numbers, and you can easily do the math, that's 4.25 million users per developer. And if they collect the feedback from one developer, you know, they will never write a line of code. So they said actually, okay, good, we have our product manager, they take care of all this feedback, prioritize that, and then we can write code. The developers can write code. That's great, that's what we want. Great, other people are sorting out what we should do, we're just writing code. Good. Well, not so, I think. Well, so, we're not Gmail at Atlassian. So we have maybe, I don't know, 10 million users and 300 developers. So just another ratio. And at Atlassian, we think everybody has to go on the front line. Everybody has to know what's going on. So we send our developers to conferences to talk directly to customers. So they know what bugs the customer here. What's the problem with our software? They know that, so they should know that. Actually, we want to close the feedback loop very, very tight and get personal. And this is also what the Jira Agile team did with this a lot of feedback. So they sat down every day for 45 minutes, went through all the feedback they got from the day before, and prioritized that. And actually, if they found something where they said, okay, good idea, but we won't do that in the next 3 years, that's not our goal. They said they actually wrote that to the guy who gave us feedback. They wrote that, and they got personal. So they said, okay, I'm a developer here, and we say we're not going to do that. And actually, what you see is actually pretty amazing stuff. People really appreciate that their feedback got down to the developer, and they said, okay, I turn you down, but anyway, okay, that's good. I understand that. And then we have another program where we send our staff to support. So we have developer on support. So our developers, we have a program, our developers have to spend at least 1 week in first level support each year. So 1 week first level support, second level support they have to do anyway. So, but first level support, 1 week. So they know actually all the first level problems. I cannot log in. Yeah, you have to use another login or whatever. So they come back with that knowledge from their support and say, hey, we can fix that very, very easily in our software. Our support people are just saying, okay, go to that page and yeah, blah, blah, blah. We can fix that in software that's easier. So there's a win-win here. Also the support people, they learn from the development. So we make debugging session with the support people so they can debug our software. They can debug Jira or Confluence. So that's developer on support. saying that about feedback and delivering kick-ass software, you should care about your customer. Care about your customer and have an effective feedback loop. Close your feedback loop very, very tight. Okay, the next thing I'm going to talk about is how to work in one kick-ass team. And you already saw that. Developers and support people are working together to solve problems. So this is, for me, one kick-ass team. Let's have a look at some other disciplines in software development. What comes there is developer and tester. Yay. So tester are good at testing software. Developer are good at writing software. That's natural that we're doing two different things. Is it? Well, we all know that if we just separate it like this, we will get problems. We will get problems in our software development. So there are problems like bottlenecks. So if we are just in front of a big release and we throw everything over to the QA, and the QA have to test it and then give back to us, well, the QA is the bottleneck here. But the most important thing is we lose the accountability. We are not accountable for what we're doing. It's the QA that is responsible for the quality. So we just give our features, throw it over the wall, and the QA will find the bugs. Great, we don't have to work for bugs. No, but we are accountable for what we're doing. It's our quality that we deliver to our customers, deliver to QA. That's really important. And what we also saw at Atlassian, if we hire, so we are very engineering driven, so we think, great, we can solve everything through automated testing, awesome, but then our customer, so we had a pretty high test coverage, but then our customers came back and said, oh, you have some bugs in your software. And it cannot be, everything is tested automatically. Yeah, you know that you cannot test everything automatically. So we learned it from testers, from QA people, that we also have to do manual tests to test our software manually. And then we thought, okay, good, how many testers do we need? And then we have a scalability problem here. At Atlassian, actually, we solved that, and now we have, for 13 developer, we have one tester. So 13 developer, one tester, that's our ratio. And we don't want to get more down. And we solved that by introducing a program called Developer on Test. So this is when developers are testing the software. So developers are testing their own software that they have written. Of course not, because another developer is testing your software that you have written. So this is developers on test. So you might say now, well, great. Developers are doing all the work, and the testers can sit there, drink pina colada, be happy, woo, and just say to the developer, test harder, there's a bug. No, it's not like this. So testers are good to testing the complicated stuff. And what we found out is actually, if we take the easy-to-test stuff and let this test by a tester and a developer, we found the same amount of bugs in the easy-to-test stuff. A tester finds the same amount of bugs as a developer. It's the hard-to-test things where testers are better. So we divide our features in, it's easy, or our QA does that, in easy-to-test, hard-to-test. And the easy-to-test things, that's what our developers get. Because quality, QA at Atlassian doesn't mean quality assurance, it means quality assistance. So the QA people are helping the developers to become better testers, to find better tools for testing. This is what the QA is, the responsibility of the QA, not just testing the software, but helping everyone to become better testers. Okay, and I told you developer on test is called DOT at Atlassian, and we have also verb for that, and it's dotting. And I bring you 6 tips for kick-ass dotting that we do at Atlassian. And the first 3 tips are just normal dotting things, and then we're getting the last 3 are a little bit advanced dotting. So if you have reached the first 3 steps, you can go on with the next 3 steps. So first, we send everyone on training courses. So we train our developers. They get to think like a tester. So they think like a tester at the end of this course. But this is just theory. So this is maybe one week course where they really get into deep testing theory. And then we also pair. We pair together, our developers and testers are pairing together. So they sit at the same desk that the developer is testing, and the tester says, if I would be you, I would test more into that direction, test more the extremes or whatever, I don't know. So this is what they do, they pair, and then we also do blitz test. And blitz test is it's another thing. It's not just the developers are testing, but the whole company is testing. So we say, okay, now we got 3 cool new features here. So we got 3 new cool features, and we want them really to be tested. So our QA is inviting people to a blitz test, which lasts maybe just 2 hours. So everybody in the company can take part of this blitz test and can test our software, our 3 new features. And the QA is saying, okay, you test this feature, you test this feature, and you just trying to break the whole thing. And then we take together the feedback. Our QA is doing that, sorting out all duplicates, and then prioritize the stuff. So this is the basic dotting, what we did maybe 2 years ago. And then we went into advanced dotting. And advanced dotting, we are writing, our QA is writing test recipes. I told you that the complicated stuff is done by our testers, which is no longer true for all tests, because they write recipes. So this is how I would test it. And then our developers can take these recipes, go through all the steps, and test the software. Another thing is what we do is split sessions. Split sessions is the opposite of pairing. Split session, we take a user story, set the developer, say, you test it, and then the tester is going to another room and test the same thing. And at the end, they come together and compare the results. And then find out that maybe the developer hasn't found all the bugs that the tester has found, and then they are discussing this. Or the other way around. And then we have something, we're experimenting with it a little bit, and it's called bug hunters. And bug hunters are actually people that say, okay, for a sprint, you're the bug hunter. You're the bug hunter here in our team now for this sprint. And then he's actually going to the done column in our Scrum board and taking the things that are already QA tested and try to find some bugs. So he's hunting after bugs. This is bug hunters. Said all that is that developers are testing and testers are testing. Quality at Atlassian is everyone's responsibility. We are all responsible for the quality. Also, we are dog fooding. That means we try our software on our own servers before we send it out to customers. So I'm also dog fooding the software. I'm trying it out. And if I find a bug, it's my responsibility also to file that bug to the Confluence team. If I find a bug in Confluence in an early beta program, it's my responsibility to file that bug to the Confluence team. Okay, one kick-ass team. Department barrier slows us down. And this were just 2 examples, support and testers. I can go on with designers. I can go on with IT administrators. So we all work from the idea to the running software on our server. We have to work together as one team. Doesn't mean that we have to do all things. We don't have to be a designer. It's good to know how the designers work to understand this process better. So we work together. We should work together as one kick-ass team. The next thing I'm going to talk about is kick-ass collaboration. And just start with coding. We are all coders, so I start with coding here. Who doesn't remember the good old times when we are the lonesome cowboy coder and just writing code? And we were the only committers in our repository. And we knew every line of code, no merge conflicts. That was great. That was awesome. And the trouble started when we worked with a team. When we worked with a team, yeah. We all of a sudden had merge conflicts. Oh, shit. And then we didn't know every line of code. Some hacky developer did this thing, and we didn't understand it, so we didn't know every line of code. And really, the quality were really different in our code base. But if we work together in teams, we need some rules how we work together. So let's have a look how other disciplines solve that, not software development. So let's have a look at traffic rules. So looking at this junction here, traffic junction, it's maybe somewhere in the US, I don't know. We see red light, maybe the cars have to stop. Wait. Green light, we can drive until the next junction, and then we have to stop again. Next traffic light, stop, wait for the other cars to drive. When we look at this, is that very efficient? I don't know. I don't think so. If we look at a junction in India, let's look at this. I don't know if you can see that, but you get the point here. So it's actually the traffic is flowing, and I've seen that video a few times. I can't see any rules in there. There are no rules, but it's stopping sometimes, but then it's going on. So it's really, really flowing. That's great. That's what we want. No rules. Great. Seems to work. Seems to work very fine. Well, said that this comparison is a little bit unfair. We know that traffic rules should protect us from accidents, and I'm pretty sure that there's more dead people in India in accidents and in traffic than in the US. So that's not fair. But if we look at our development, we have so many rules. Our company gives us so many rules. And what does actually development rules protect us from making mistakes? But does it really mean that we need to have that many rules? I've worked for a company that said, okay, we have to write our process down, our whole development process. And it looked a little bit like this here. If you do A, go to B, or go to C, or... Well, I actually had to write things like that down. It's not a development process. So. But when we look at coding processes, please keep it simple. At Atlassian, it's very, very simple. We have just these three things: branch, pull, merge. So we're doing actually a branch for every task. So we're using Git, and we're doing a branch for every task that we have. So a task is at Atlassian an issue, in Jira, of course. So we take that and make a branch for it. And it's very, very short lifetime. So branches have very, very short lifetime, an average of 2 days. After then, we merge it back and delete the branch again. The problem is solved. It's in the master branch. We are done. Well, this is not the whole process. So let's add some quality here. So we ask people, we're using pull requests, and we ask people, hey, what do you think about my changes? And this is in our process. This is baked in our process. No line of code gets into the master branch before it's got reviewed. So, but actually, why do you want to discuss our changes? So I've actually here my game show candidates who can answer me that questions. And I asked the question, why do you want to discuss the code changes here? So who wants to press the button first here? Julie. She wants better quality. That's good. That's a great answer. Of course, if we discuss the changes, we get better quality. We get into this discussion. Well, this is good. This is bad. Well, looks like infinitive loop. Well, this if statements, you never reach that. So we get better quality here. Somebody else wants to press the button? Lynn. And you cannot see the answer from Lynn, but it says, what does it say? Thank you, Steve. She wants to learn. And that's so true. We learn so much. And this is, I think, the most important thing if we do code reviews, if we discuss about code. We learn from each other. We not just learn how the other people are solving problems, we also learn some parts of the code that we have never seen before. But other people can touch that because they know that part. And we just get pulled in the pull request, and we see all of a sudden what this PDF importer class is doing. And say, oh, yeah, that's great. OK, next one. Andy. Andy, come on. Andy wants to feel better. So he feels better about the code changes. If they discuss code changes, Andy feels better. And that's also so true. And I'm also feeling better if somebody else is looking over my code. That's great. So if we put it into production and the server goes down, I can say, well, we all have looked at that code, and we all haven't seen that bug. Good. Well, I have to fix that anyway, so it doesn't matter. But I feel better. Steve, come on. Answer, Steve. I want to blame people. Wrong answer. We don't blame people in pull requests or in code reviews. We want to be gentle. So be respectful when discussing changes. And then at the end of a pull request, you approve the pull request. If you're happy with the result, you approve the pull request. And we have a rule at Atlassian. We invite maybe 5 reviewers. And if we have 2 people approving the pull request, 2 thumbs up, we're good to go. We merge the code. We don't wait for everyone to review our code. So it's just 2 people, great, or 2-3 people, depending on the team, great. So that means we have fast development. So when we're not just talking about code, we also have to collaborate around other things. And we are distributed over the whole world. So we have offices in San Francisco, in Gdansk, in Vietnam, and in Sydney. So this is where our development sits. So, and we prefer actually co-located teams that sit together in one office, and we think the collaboration is much better. But said that is, the truth is that's not always possible. People are traveling, people want to move away, and we don't want to lose them at Atlassian. We acquire new companies, and they work maybe on a Canal Island and on Gimsey, actually. Our source tree is developed on Gimsey. So we are really, really highly distributed. And then another thing comes to my mind is actually, where do you work best? Is that actually in the office with all people? Or is that in the coffee bar next door? Or is that on your couch at home? And the answer here is, it depends. It depends. I mean, if I want to collaborate, if I want to talk to people, the office is maybe the best place. If I really want to concentrate, maybe the coffee bar or my couch at home is the best place. So the question is, how do we actually connect all these dots here and collaborate effectively? How do we do that? And there's one great thing that we all use day in, that we just have to use it more efficiently, and we use it at Atlassian heavily. It's called emails. Emails are great. So let me tell you about emails. Emails work offline, which is cool. I can write my emails on a train. One too many. I just can write one email and reach many people. That's also good. That's great. They work asynchronously. Yeah, I don't have to answer directly. I can wait one day and then answer. Cool. And then I can add people to the conversation. Also great. I can just forward emails and show the problem to other people. That's good. Well, we love emails at Atlassian. You might think that now. Are you crazy, Sven? This is how my inbox looks in the morning, actually. It's way too much emails. Okay, good. We all know that email doesn't really work. So, emails are bad for conversations. Discussions on emails are not working. Lots of spam gets in. We get every email needs an action. I have to delete it. I have to put it somewhere. And they are often too long. People are writing really epics in emails. So, we want to avoid emails as much as possible. And that's why we use chat at Atlassian heavily. Very, very heavily. Who uses chat here at work? Oh yeah, half of you. That's great. We have a lot of chat rooms. So we have maybe over 100 chat rooms at Atlassian. And this is something like, for example, the Confluence developer chat room, where the Confluence developer hang out, discuss code and new features. Then we have the design team. The design team has its own chat room where they discuss their mock-ups and their design things. And then we have something like an enterprise discussion room. When I got a question from a big company, I just jump into that room, and they are the experts, so they answer my questions, and then I can leave that room again because I'm not interested in all these enterprise discussions. But just if my question gets answers, I'm happy. I leave that room afterwards. And then we have something like beer drinkers or cat lovers chat rooms, and I have no idea what's going on there. But the most important thing is here, you need just the conversation you need in order to kick ass. We want to kick ass, so just have the conversations you need to kick ass and stop all the rest. And what we found out actually when we went into this chat room thing, that we put up temporary chat rooms. And temporary chat rooms are great for when we have a cross-team project here. So if we want to do maybe a new web page for our HR, we want to hire new developers, so we have to set up a new web page, and we have all this knowledge in-house, so we don't ask a consulting company to do that. So then we're creating a temporary chat room where we have the designer talking to the marketing guys, and of course talking to the HR and the web developers. So they talk all together in this temporary chat room. They don't have to sit in the same building. They don't have to sit on the same continent. They're connected through this chat room. And then, of course, you have to also involve the management, maybe. Well, that's just randomly emoticons here. I don't know how that happened. Anyway. And then actually, when we have created the web page, we delete the chat room again. It's just a temporary chat room. So, but chat is also great, of course, for remote conversations. We all know that if I'm actually in my home office all day, and it connects me to the office. So it's great for remote conversations. But not only that, it's also great for local conversations. So what people do at Atlassian is they stop that much talking in the development room. They start chatting, because if one is in the zone, he's just in the zone coding, closes his chat client because he wants to stay in the zone, and then and when he comes out of the zone, he can follow the conversation because there's a history in the chat, so he can see all what's happening during he was in the zone. So this is great, and this is also a reason why it's great for conversations different time zones, because if the Sydney team gets to bed, the San Francisco team wakes up and looks at the chat room and knows why some decisions has been made like they has been made. So they can see that in the chat room. There's a history. They can jump into the conversation, understand what's happening. That's great. Another thing is that you can pull people into conversations, and you just need to mention them. So you just say, @Thomas has already had that bug, and then Thomas got mentioned. He got a notification, and he get dragged into the chat room. So we use chat heavily, and I encourage you to use chat too at your work. And then, if I talk about collaboration, we had another problem in our Sydney office where, well, we expanded heavily in Sydney. So we had on one side of the street a building, and then we expanded to the other side of the street. And even though there was a traffic light somewhere 100 meters down the street, people didn't use that. So if they had to use If they had to go to other developers, they had to cross the street, and it's very, very, very heavy. And you know, software developers in Australia, they are rare. There are not so many, and we don't want to lose them. So we needed to find a solution for that. And then a developer watched a movie, this one here, Stargate. We said, yeah, that's a solution. We are stupid. We built a portal. That's good. Well, we kind of did. So this is our portal in the year 2014. So, well, it's just a TV screen with a Mac Mini and a small camera. So you have a small camera up there, and then we have one in the one building and one in the other building, and then you can really start conversation. You can look into the office and wave and things like that. So it really feels like you're looking in the other's office. And it's this conversation, if you stay in front of the TV screen, it's much better than just using your computer, webcam, Skype connection. So this is really great. Well, talking about collaboration, remove collaboration friction. Everywhere you see friction in collaboration, remove that, and think about your workflows, especially your coding workflows. Easy workflows means fast development. The last thing I'm going to talk about is automation. We are software developers. We love automation. So what are we doing day in, day out? Well, we are helping people to be faster. We're helping them to be faster by automating their work. Great. That's what we help. That's what our software is doing. But the question is actually, how much time do we spend to automate our own software development to be faster? Not that much, I think. So when I talk about automation, the first thing that comes to my mind in software development is continuous integration. So who's doing continuous integration here? Not all hands goes up, but anyway, okay, good. From those who's doing continuous integration, who's actually doing kick-ass continuous integration? One. Okay, good. Come up stage here and explain us how to do it. Because we fail also with kick-ass continuous integration, actually at Atlassian. So if we look at our builds, they really took too long. 2 years ago, we were looking at our builds, and they took too long. They were way too complicated. They were unstable, and they really missed the concept. We didn't have a real concept. I have to hurry up here. Okay, good. So this was a problem with our builds, especially Jira. 11 years old software really was long. So in short terms, our builds sucked. But what we want to achieve is we want to fail fast. Actually, I want to check in my code, and I want to see immediately if my build is green, if all tests run through, if I can build it, and if all performance tests run through, that would be perfect. We're not there yet, but we're getting there. I call this 4 things, how to tame monster builds and how to kick ass again. We're not there yet, we're not kicking ass, but we're trying hard. We looked at our builds and tried hard to fix things. So the first thing is a little bit embarrassing, but this is the truth. What we did is pass the artifact. So build the thing and check it into your Nexus or Artifactory, whatever you have or whatever you want. Check the artifact in there and take it from there. Take everything from there. And we were building it, I don't know how many times. So these are the stats, actually. We went down from, good that you cannot see the numbers here, very good, but it's 1 hour down to 30 minutes. Really embarrassing, but just passing the artifact. The next thing is making tests parallel. Do them in parallel. So just put in more power into your continuous integration server, have a second one, a third one, and run your test in parallel. That fixes a lot of things. Then we looked at our strategy, our build strategy. And we saw we had this idea of a build pipeline. So first we build, then we do UI test, then we do performance test, then we do, you get the point. So that's what we had. That was slowing us down, actually. So what we do is now we build in steps. Or in layers. So the first layer is every check-in, we're building and making unit and UI tests. This is what we do with every check-in on the master branch. Then maybe hourly we're doing the platform test, and then maybe just the performance test we're doing on nightly basis because they take so long. And we find, I think 98% of all bugs we introduce here, so this is good. And if we don't fail fast here on that stages, but anyway, it's just the rest 2%. And then look at your statistics. So look at your stats, how does your build perform? And then you can maybe see, okay, this takes too long. I have to split it into 2 tests. Because faster builds means actually less task switching. We want to switch less tasks. When we are on task A and we make our build and we have to wait 1.5 hours, we already started with task B and then our build breaks and we have to go back to task A. This is not very efficient. We want to go grab a cup of coffee maybe and then go back and then we see if the build succeeded or not. More test automation. Awesomeness. So what we also have is a flaky test detector. So this flaky test where your build is red, and then you say, okay, I run it again, and then it's green, and then you're fine. That's a flaky test. So we have a detector that detects that. Nothing changed in the code, but it was red and green, so this must be a flaky test. So it puts it automatically in quarantine. So this test is not executed anymore, and it's automatically raised a JIRA issue, so somebody has to look at it. So it doesn't say anything if once it succeeds and once it fails. So we can put that away for a second, but somebody has to look at it if it's really relevant. Then we have wallboards all over the place. So every software development team has a TV, at least one. Most teams have 2, and you can see actual numbers on that. Whatever you want. Some teams make that differently, so you can see how many builds succeeded, how many builds failed, what tasks do we have right now, who is working on what task, whatever. Then we have a static code analysis, which is our Freud bot. So we put that into pull requests. And if we do a pull request, the Freud bot kicks off, looks at the code statically, analyzes it, and puts in automatically comments into the pull request and says, hey, this is a magic number here. Maybe you want to use a constant. So said that is use your skills to automate things. We are software developers. We can automate things. We have to look at our own software developments and fix things there and make our development faster. So 4 ass-kicking topics, but these were just randomly picked from me. I just went through Atlassian and said, oh, this is great, this is good, this is where we kicked ass. These are just random puzzles. I could have picked 4 different ones for other ones. Know your priorities. What are your priorities? What are you looking at? Kick-ass customers, kick-ass team. You want kick-ass customers, you want a kick-ass team, you want kick-ass dev speed, kick-ass quality, kick-ass scale. But where's your priority? Or maybe you are more into quality. The software requires more quality. Then maybe this is a higher rated thing here. But know your priorities. At the beginning of this talk, I asked you the question, or I raised the question actually, is Agile dead? No, of course not. I mean, all these things were Agile. We are constantly adapting things. We're seeing this is not working, so we change it. Maybe it's not the Scrum process or whatever. We don't care. We just want to make things work. We want to kick ass. We don't want to follow rules. We want to kick ass. This is what we want to do. It's like running a triathlon. So Scott Farquhar, our founder, once said, be excellent in everything you do. Well, you can't run a triathlon if you're just good at running. You have to be also good at cycling and at swimming. So look at your software development and tackle everything. It's not just good if you have kick-ass automation, your build servers are running very, very fast, but you suck in collaboration. You also have to fix that. Be excellent in everything you do. Every time you see a flaw in your software development, try to tackle that and fix that. You might say now, okay, we know all the flaws in our software development, so we go to our managers and tell them, but actually, managers are humans too. Managers are humans too. Yeah, I agree. Some are maybe easier to persuade, and some may be a little bit harder to persuade. I don't know. So, but what you want to do is actually, you want to build a kick-ass culture. That everyone that sees something jumps on it and tells the team, this is really bad, we have to fix that. It should be. It's not happening if you're the only kick-ass software developer in your company. It's not happening. It's not working. You're not going to kick ass. You have to build a kick-ass culture. The whole team has to be a kick-ass team. And at the beginning, I started this talk with this one here, kick-ass. You see, he got stabbed by a knife, driven over by a car. But he stood up again. And you have to stay up also. You're not changing things. If you're sitting all day long behind your screen, typing in, maybe writing an email to QA, yeah, we have to do dotting. I heard that at a talk at the Jacques Cologne. Please let us do that. No, you have to stay up. You have to actually get out of your comfort zone in order to be more awesome. If you want to be awesome, you have to step out of your comfort zone. So at Atlassian, we have different teams, and I'm finished in a sec. Different teams with different names. Every team can pick randomly a name. So we have the A team, the Black team, the Muppet team, and of course we also have a kick-ass team. And they have this poster at the wall. And it says, did you kick ass today? So every time they leave the office in the evening, they see that and they ask themselves the questions, did we kick ass today? And I want you also to ask yourself the question when you go home every evening, did I kick ass today? Thank you.
Okay, 10 minutes break now.
Wait. We're getting over.
Oh. You want the mic?
So I'm going to give you this. You're going to help me.
Ah, okay.
You're going to kick ass
I'm trying.
with robots.
Oh, cool.
Here, have a robot.
Cool.
Okay, so I promised you guys demos. And there's all the countries I'm traveling to. If you have any buddies in any of those countries, let them know I'm going to be zooming through on my motorcycle, and they should come to the local Jug event. All the pages are posted. All right, so let's kick some ass with Lego Duke.
Right.
So Lego Duke is built using the EV3 Mindstorms. And on the back, he has a little CPU. It's actually an ARM processor. And this is powerful enough to run the full Java SC embedded. So the same, basically the same code that was running the Raspberry Pi earlier, but this time it's on a Lego using the Lehos libraries for sensors. So we have wheels, we have an IR sensor appropriately positioned in his buttocks. We have a gyro inside of him, and of course a nice Lego shell. So lay Lego Duke out on his back.
On his back?
Yeah, on his back. And then you're going to press the button in his hand.
I don't know.
Yeah?
Should I?
Yeah, go.
I did.
All right, so, hey, Michael. You see that computer in front of you? The Mac down below, in front. No, not that one, the other one. Yes, the one you're pointing to. Press return on the keyboard, because I think I forgot to run the program. You were so close to starting, to finishing several times, that I rebooted the program several times. Is it like spamming random stuff now? Yeah, okay, try again. Come on, we want to kick ass with Lego Duke.
Yeah, come on.
Now just click. Okay, now you want to stand them up quickly.
And run.
Just like a bomb. Okay, now he's running a little segue algorithm. So as the gyroscope tells him he's like tipping forward or tipping back, he's going to try to compensate. You guys use segways at Atlassian to get around, to get across that dangerous street? No. Okay, and we have a little IR remote here. Let's see if we can give Duke some commands. Now, For folks trying this at home, I would highly disrecommend running your robots on tables, especially the ones made out of Legos. But we'll see. This was the most flat surface. Okay, so you can turn and you can go forward, not too fast. Yeah, okay. You went a little forward, a little too far forward, and you can turn to the right. Ah! Okay, so just a quick example of what you can do with Legos and Java running directly on the Lego device. This is running a full JVM and the new Java 8 release, which we're celebrating the launch of. So thank you and enjoy the break. If you want to play with Lego, do come up during the break and you can try them out. And thank you.